Okay, let me talk about deriving formulas. Someone says, well, if I can remember it, do I need to derive it? No, you don't need to derive it. But there's so many things to remember that it becomes almost impossible to, conjure up certain formulas. So this one over here, I realize that you might say, why do I even need that? The problem did, kind of devolve into something that looked like this over here. So what I want to do is, I don't remember this, by the way, but I do remember, I remember cosine, a plus b. I remember cosine a minus b. I remember sine a plus b. And these are also derivable, by the way, and the sine of a minus b. All right? So I'm going to say I remember that stuff. All right? There's not much, but I do remember that. One thing nice about those sum difference formulas, they produce a tremendous number of other formulas. Double angle formulas, half angle formulas, product to sum formulas, sum to product formulas. It's just amazing how many things it's producing. So what I want to do is go through the cosine of a double angle. And cosine, I'm going to write it down as a plus a. What's that going to be? Cosine a times cosine a minus sine a times sine a. So really what I'm saying is cosine of 2a is equal to cosine squared a minus sine squared a. All right? That's what's known as a double angle formula. What's interesting about this one over here, there's other forms of it. So what I want to do is remind you that another identity that you should know is the Pythagorean identity, and that is sine squared of a plus the cosine squared of a is equal to 1. So I could write this thing, cosine of 2a. Well, the cosine squared is really just 1 minus sine squared. All right, we just took care of this. Now what do you get over here? Minus sine squared of a. Let me write this down now. Cosine of 2a. This is 1 minus 2 sine squared of a. All right? So, I kind of have a couple different formulas right now. I got this one for a double angle formula. I got this one for a double angle formula. I can write another one down. So what I'm going to do over here is I'm going to say, well, let's make a substitution for sine now. So cosine of 2a equals, I'm using this by the way, cosine squared a minus sine squared. Well, if I thought about that, I got to subtract that away. What's sine squared going to be? 1 minus cosine squared. Write that down. Whoops. 1 minus cosine squared of a. What do you get over here? Cosine 2a. And then I get 2 cosine squared a minus 1. All right, I'm going to say that what happens to a lot of students, they kind of remember that they did this in pre-calculus, but they really can't remember everything that's needed, right? Now, I just did it. It's fresh in my mind. I'll write it down again for you. Use different letters now. The cosine of 2 theta is cosine squared theta minus sine squared theta. It could also be written out as 2 cosine squared theta minus 1. It could also be written as 1 minus 2 sine squared. Now, I realize someone's going to say, how does it relate to this thing over here? Well, I kind of see something like that. All right, let me put this over here. And I want to see if I can do it. I see cosines and sine squared. So I'm going to say they're all cosine 2 theta, by the way. But I'm going to take this last guy, and instead of putting 2 theta down, I'm going to say 2 theta is equal to x. And if that's true, then theta would be x over 2. Let's write that down. So cosine, well, what's 2 theta? I decide to call it x, right? 1 minus 2 sine squared. What's the theta? Oh, it's x over 2. All right? I'm going to try to, rearrange it to look like what's up there. And what do you get there? 2 sine squared x over 2 equals 1 minus cosine of x. What does this accomplish, by the way? It accomplishes taking, a square and writing in terms of linear functions, or taking a linear, when I say linear powers of cosine, and write it as squares down. Is this the one that's been provided to me? It is. It's right over here. Thank you.